In this video, we will learn how to determine empirical and molecular formulas from given percentages or other information. The first thing we need to do, though, is make sure we understand what an empirical formula is. And what an empirical formula is it's a reduced formula that shows a specific ratio of elements in a compound. Whereas a molecular formula, which we'll deal with at the end of this video, shows the actual formula, and it's not reduced whatsoever. And so, for example, P2O4 could be considered a molecular formula, and since I have 2 and 4 and those are both divisible by 2, we would say that PO2 is the empirical formula. Okay, so what we're going to do is we're going to be given a sample, and there's basically 4 steps that we need to do, and they kind of have a nice ring to it if we think about it in this way. Percent to mass, meaning if I'm given percents like I am in this problem, I'm going to go ahead and convert all of those to just masses or grams. And then once I have the grams, I'm going to convert them to moles. And then I'm going to compare all the moles. So in this problem, I'll have moles of nitrogen, hydrogen, sulfur, and oxygen. And I will divide each of them by the smallest moles. And I'll have to do the math there to figure that out. And then step 4 would be multiply until you're whole or by a whole number. And I always put an asterisk next to that one because that step is only necessary sometimes. Okay, so let's look at this example problem A. What I'm given is I'm given a percent of nitrogen, a percent of hydrogen, a percent of sulfur, and a percent of oxygen. And what I'm going to first do is step 1. And step 1 is percent to mass. So I'm going to convert all my percents to masses. So 21.2% nitrogen is going to be converted into 21.2 grams of nitrogen. And then I'm going to convert 6.10% hydrogen to 6.10 grams of hydrogen. I'm going to convert 24.3% sulfur into 24.3 grams of sulfur. And then I'm going to convert 48.4% oxygen into 48.4 grams of oxygen. So I have done percent to mass. Step 1 is complete. Now that I have all these grams, I'm now going to convert them to moles. And I need a calculator and periodic table to do that, so make sure if you're following along you have those out. And I have actually all these molar masses memorized, so I don't necessarily need to flip back to my periodic table. But there's 14.01 grams of nitrogen in 1 mole of nitrogen, and when I solve that out with my calculator, I get 1.51 moles of nitrogen. There's 1.01 grams of hydrogen in 1 mole of hydrogen, and so when I solve that out, I get 6.04 moles of hydrogen. There are 32.06 grams of sulfur in 1 mole of sulfur, and so when I solve that out, I'm going to get 0.76 moles of sulfur, and then there's 16.00 grams of oxygen and 1 mole of oxygen, and so when I solve that out, I'll get 3.025 moles of oxygen. So I've done mass to moles. Now step 3, I'm going to look at all my moles, and I'm going to divide by the smallest one, and so when I look at these, I've got 1.51 moles of nitrogen, that's not the smallest. 6.04 moles of hydrogen, that is not the smallest. 0.76 moles of sulfur looks to be the smallest. And then I've got 3.025 moles of oxygen. So I'm going to divide each of them by 0.76. And I'm going to see what number I get. And I end up getting 1.99. I end up getting 7.95, I end up getting 1, and I end up getting 3.98. And a lot of chemistry students don't know how to round these numbers, and I say that if you're within 0.1 or a tenth of the next whole number, it's okay to round. So this 1.99 is going to be 2. This 7.95 is going to be 8. This 1 will be 1, and then this 3.98 will be 4. And so I actually have solved for the empirical formula of this. This is going to be N2, H8, S1, and then O4, and again, we don't have to put the 1 with S, and that is actually the final answer. Some chemistry students might be able to look at this and figure out what the name of this is. This is technically ammonium sulfate, or NH4 2SO4. Okay, let's go ahead and look at another example. We are given 69.8% iron, 30.2% oxygen. So my first step is percent to mass, so I'll take 69.8% iron, and I'm going to convert that to 69.8 grams of iron. Then I'm going to take 30.2% oxygen, and I'm going to convert that to 30.2 grams of oxygen. So I've done percent to mass, that's my first step. Now I'm going to convert these to moles, each of these to moles, and I'm looking at a periodic table in front of me. There's 55.85 grams of iron in 1 mole of iron, and then I'll do the same thing for oxygen. There's 16.00 grams of oxygen in 1 mole of oxygen. So I get 1.25 moles of Fe, and then I get 1.89 moles of O. And then now I need to look at the 2, and I need to divide by the smallest one, which will be 1.25. And then that gives me 1 of iron, and that gives me 1.51, which we can say is about 1.5 for oxygen. And this is where step 4 is going to come into play. If I stop right now, I end up with a formula of FeO 1.5, and that doesn't make a whole lot of sense. We can't have 1.5 atoms of oxygen in each formula. That just doesn't make sense. We need whole numbers. And so what I need to think of is what number can I multiply 1.5 by to get a whole number? And basically, if I have something that's 0.5, I'll end up multiplying by 2. If I have something that's like 0.33, I'll end up multiplying by 3. Or if I have something even 0.67, I'll end up multiplying by 3, because that's like a third, that's 2/3. This is 1/3, this is 1/2. Or if I end up with something like 0.25, that's 1/4, so I'll multiply by 4. Or even if I get 0.75, that's 3/4, so I'll also multiply by 4. So I need to think about it in terms of something like that. And so I look at this, I've got 1.5, so I'll multiply that by 2. But just like in algebra, if I multiply by one thing by a number, I need to multiply the other number by that as well. So I get 2, and then I get 1.5 times 2, which will be 3. So my final answer is Fe2O3. Okay, so let's look at another example. Let's look at letter C, and this one's going to be, or actually, let's skip to letter D. This one's a little bit different. Normally, we've seen examples where we're given percents, and in letter D, we're actually given moles. So what that means is if I scroll back up here to my steps, if I'm given moles, that means I've done step 1 and step 2. Those have been done for me. So what I want to do is I want to just do divide by small, because I've done mass to moles, or it's been done for me, and so I'm given each of these. I'm given 0.0130 moles of carbon. I'm given 0.0390 moles of hydrogen, and I'm given 0.0065 moles of oxygen. So I'm actually at the step where I just divide by the smallest, and if I look at these numbers, it looks like oxygen is the smallest, so I'll divide each of these by 0.0065. And when I do that, I get 2, 6, and 1, and I get C2H6O. And this is ethanol, actually. And typically, if you take organic chemistry or another chemistry class, you may see ethanol written as C2H5OH. And the only reason it's like that is so you can see that it's bonded in this way, but that is beyond the scope of what we're trying to do right now. Okay, so that's ethanol. Now, let's look at some examples where we are solving for molecular formulas or not reduced ones. And so this first step is we're just going to get the empirical formula. So let's go through and let's look at number 1 here. And I'm going to go through, I'm not worried about the molecular formula right now. I'm just going to get the empirical formula just like we've been doing. And I'm given 68.54% carbon, 8.63% hydrogen, 22.83% oxygen. And so I'm given percent, so my first step is percent to mass. So I'm going to take 68.54% carbon, turn that into 68.54 grams of carbon. I'm going to take 8.63% hydrogen and convert that to 8.63 grams of hydrogen. And then I'm going to take 22.83% oxygen and convert that to 22.83 grams of oxygen. And then my second step will be converting these grams to moles. That's very common in chemistry, so we see that in these steps. There's 12.01 grams of carbon for every 1 mole of carbon, and when I math that out, I get 5.71 moles of carbon, and I'm not worried about rounding because I still need to divide by the smallest moles. A common mistake that a lot of chemistry students make is that the second they're kind of close to rounding is they'll go ahead and round, and that's not where we're at right now. And so this is 8.54 moles of H, like I just finished saying. I'm not ready to round. And then there's 16.00 moles of oxygen and, 16.00 grams of oxygen in 1 mole of oxygen, and that maths out to be 1.43 moles of oxygen. I'm going to now look at all my moles, and it looks like oxygen is the smallest one, so I'll divide each by 1.43. And when I do so, I'm going to end up with 3.99 for carbon, 5.97 for hydrogen, and 1 for oxygen. And so this 3.99 is within 0.1 of 4, so I'll round that up to 4. 5.97 is within 0.1 of 6, so I'll round that up to 6. And so what I've just done is I've solved for my empirical formula, and that is C4H6O. And so now I need to worry about how to turn that into the molecular formula. So let's go back to our notes and look at how we're going to convert to our molecular formula. Is we need to calculate the molar mass of our empirical formula, and then I say here that we're going to calculate the molar mass of our molecular formula, but most of the time this is usually given. Okay, so this is going to be given. I think I spelled usually wrong. That's embarrassing. Oops. So this is going to be usually given. And in our problem, we are given it's 140 grams per mole. So what I want to do is I want to get the molar mass of C4H6O, and that is going to be 70.10 grams per mole. And now I'm going to use this formula, and I'm just going to compare them. I'm going to take the molar mass of the molecular, which in this problem, that's 140 grams per mole. And I'm going to compare that to the molar mass of the empirical, which is what I just solved for. And that is 70.10 grams per mole. I'm going to divide them and see what I get. And I get a decimal, but it's essentially 2, meaning to convert my empirical, this guy over here, to my molecular, I just need to multiply it by 2. So I'll take 2 times C4H6O, and that'll convert it into the molecular. And that will be C8H12O2, and that is our final answer.